Algebra 2 students, this is a video regarding lesson 6.7, or the start of that, dealing with roots and zeros. So just a little clarification, we've been talking about this a few times already, but these statements are basically equivalent, which means if one of them is true, all the rest of them are true. That c, or x, or whatever a variable would be, is a zero of the function, then we know that that same c value is a root or a solution to that function equal to 0. We would also know that x minus c is a factor of f of x, and that the point c0 would be an x-intercept. So basically these terms are very interchangeable as far as zeros of the function, a root or a solution to the equation, a factor of the function, and an x-intercept of the graph. Then a couple theorems. The first one being that every polynomial will have at least one root, which means also solution or zero, in the set of complex numbers. So every polynomial must have at least one. That could be imaginary, that could be a real number. It could be one that's used more than once, or a multiple root. Also, a polynomial p of x equals 0 of degree n. So if it is degree n, then it will have exactly n roots, or n zeros. That would include any imaginaries, and it would include any repeated roots or zeros. And we'll talk more about what that means later on here. Then the number of positive real zeros is the same as the sign changes, or less of this by an even number. The number of negative real zeros is the same as the sign changes of p of negative x, or less by an even number. So if we replace x with negative x, we're going to be determining the number of negative real zeros or positive real zeros. So in the first couple of types of problems here, it's asking you to solve the equation and state the number and type of roots. So for this first one, we do have an x squared. This is second degree, meaning we're going to have two roots. They could be imaginaries, they could be the same root, and so on. So what we would do is we would solve this. And in this case, it is a quadratic. If I use my factoring techniques, there's no greatest common factor. It's not a special one. It's not grouping. I would use trial and error. I'd have to have x and x. The minus 21, the minus means I need one of each. And then factors of 21, I need a positive 4. So I believe 7 and 3 would work. And therefore your solutions would be positive 3 and negative 7. So as far as the type and the number of roots, there are two of them, and they are real, and in this case they are rational. We have two real rational roots. The next one, if I'm going to solve this by factoring, is there a greatest common factor? Yes, I could take a 2 out. I could also take an x out, and I'd be left with x squared minus 25. And then this x squared minus 25, that's an example of difference of squares. So I'd have x and x, 5 and 5, minus and plus. My solutions would then be 0, positive 5, and negative 5. So in this particular case, I've got 3 roots. Those are real numbers, and they're also rational. Rational means could be written as a fraction. Again, it's third degree, as you can see, and I have 3 zeros or roots. Next one there, greatest common factor, there is not one. Is it a special one? I believe it is, because this is a perfect square. It's a little bit larger than on our list, but this would be an example of difference of squares. It could be factored to be x squared and x squared. 625 is 25 times 25, and I would need different signs. Now this is an example of difference of squares. So I'd have x minus 5 and x plus 5 in any order. The x squared plus 25 I would not be able to factor. Solutions would then be positive 5, negative 5, and now what makes this equal 0? It'd be a negative 25, and since it's x squared, it'd be a positive and negative square root of negative 25, which would be a positive and negative 5i. All right, so then, what do we have? We do have 4 solutions. I have 2 real rational ones, and I have 2 imaginary. So I have a total of 4. It was a 4th degree equation. Next example is a 5th degree equation. I could take an x to the 3rd out. That's going to leave me with x squared plus 4. And then I don't think there's anything more I can do. My solutions, what makes x cubed 0? That'd be 0. What makes x squared plus 4? So it'd be a negative 4. Since it's squared, I'd have a positive and negative, which could be simplified to be positive and negative 2i. So in this case, we have 1 real rational root. I've got 2 imaginaries. But since I had an x cubed here and a solution of 0, that 0, that real rational root, is what we call a triple root. So that basically counts as 3 of them. So I've got the 1 times 3 and the 2, which together is going to give me 5, which this was a 5th degree equation. So these are some examples of how to solve the equations and determine the number and the type of root.